Hello YouTube, iFixItAll here, Team iFixItAll. What we've got today is a very unhappy windmill. This was made out of I gutted an old ceiling fan. All the parts are from a ceiling fan excluding the heart-shaped tail fin. It originally had the ceiling fan blades on it, and nature taught me a lesson. So if you ever do want to make a windmill out of an old ceiling fan, sure, use the old blades if they're plastic, but if they're particle board, well, they'll self-destruct the first rain you get. So I made these out of drain pipe, and they lasted several years, and I've done some repair on the blades. It's time to make a new set. Let's see how we go about doing that. Hang tight, let's get started. Alrighty, so I got some drain pipe, and what I did was, in order to make sure I was square on either end, I measured from a reference point that was new up to here, and I just picked an arbitrary number. I think this comes out to be 22 and a half. The original blades are about the same. And what you have to do is determine the spacing. I need 5 blades, and I've got 1 piece of pipe. So make a random mark. As for instance, I made a random mark right here, not this one. A little insight, I screwed up the first video, so part of the work is already done. So I'm going to be talking through how to get set up. Make a random mark. Let's just use that as a random mark. And what you want to do is determine what your circumference is by just using a ruler. You could do the math on it, but let's just see what our circumference is. And it comes out to, oops, get a steady hold on it. Roll it around. There we go. Okay, I'm on it now. And it comes up to be 13.75 inches around. Okay? 13.75 or 13 3/4, but we're going to convert our fractions into decimals so that the calculator doesn't have to fight with me. 13.75 divided by 5 blades means each blade needs to be 2 3/4 inch diameter to use up all this pipe, and plus that wide of a blade agrees with my windmill. It can accept that. So then you make you up a paper jig that's 2 3/4 inches, and you pick any arbitrary spot at the end, make your mark, center line over the marks, the edges of your paper. You make all your marks, and I come up with perfect 2 3/4 all the way around with Sharpie marks. This is tapered, by the way. So what that means is, on the other end, you need to first square up. Square up. So pick one of your marks, get you a square. Let's see if you're in frame if I do this, which you aren't. Get that out of the way. I'm going to pick this mark here. Let's see if you've got all the going-ons going on. Yeah, well, that would be good enough. So, got a mark down here. I'm going to lay that against the edge of my square. And I'm going to come up here and make a random mark. Well, I'll just make a mark not on the edge, but down low. There's purpose for that. Now that I have this square with this, I have a random mark right here. Oh no, that's actually a calibrated mark, I'm sorry. It's square. With that, I'm going to scoot over counterclockwise 1 inch. And I'm going to use a piece of paper. Full stop. I've got my square mark. Now I need to determine what is the circumference of this. So I get my ruler again. And get my approach right so I don't bump into my light over there. This end is a different diameter than this end. That's why I've got to make a new spacing measurement down here. So from my mark that's square with this, which I just did with my square, I'm going to learn what my circumference is. And it's telling me 13 1/8. Well, what is 1/8 in decimal form? 1 divided by 8 is 0.125. So it's 13.125. 13.125 divided by 5 blades is 2.625. What is 2.625 in fractions? Because I'm more of a fraction guy. I think that's 5/8. 5 divided by 8 is 0.625. So 2 5/8 spacing. So now, when I used my square earlier, where I had this mark that I made with my Sharpie, I'm going to offset 1 inch. And I've got my jig here made up to be, remember I deleted the other video, this used to be wider, but I had to trim it down to get it to be 2 5/8 inches wide. This jig here is 2 5/8. So I offset, make a tick mark, and I start there, and I space these out at 2 5/8. Get your Sharpie mark, and you come up with 1, 2, 3, 4, 5 blades. Double check that. 1, 2, 3, 4, 5 blades. Okay. I'm going to ignore this square mark from now on. In fact, we'll try to smudge that out of the game completely. What we're after is blades that are going to be shaped spiraled, like the blades are going to be curved, corkscrewed, spiraled. If you just simply chop these out squared off with one another and put them up on your fan, the fan's never going to turn right. You have to have that blade curved. So we're going to build in a natural curve. So the way I'm going to do that now is I've got these marks down here, and I've got these marks up here. These marks, these up these marks up top are a little bit offset from the marks on the bottom. I'm going to join them up with my handsaw. If that handsaw is long enough. Looks like it's just good enough. This might end up being a one-handed thing. Doesn't have to be perfect. Okay, got that one. Let's see what we got here. We should have a mark down here. Oh yeah, we sure do. This is working out okay. I'm actually holding it with my thumb here, but pulling it that way so that the wooden handle gets in a bind on the base of this. Seems like it's working out okay. Hopefully you can start to see what we're achieving now. We're achieving a line that is sort of corkscrewed. And that's what our blades need to be when they're mounted on the windmill in order to catch the wind and react to it. I'm not left-handed either. I saw a YouTube video, or a thumbnail for one. The science behind why some people are born left-handed. And I'm like, oh, there's a science to that? We know why? Science claims to know a lot until they... Oops, damn it. Okay, science claims to know a lot until they don't. And get this mark lined up. Okay. See what we got? We got a spiral going on. So now what I'm going to do is, now that in my mind I can imagine seeing the blades now, what I'm going to do is skinny the blades up as they move toward the end. I should have done that already, but it's quite all right. I'm going to, what I mean by skinny them up is on the old windmill, they were fat at the bottom, and as they progressed, they got thinner. So I think what I'll do is, I don't have to be precision on that, I don't believe. Actually, I do, because if the blades are a different weight, so I'm just going to fold back some of this paper here, and I'll just call that the width of the upper end. Let's see what I'm doing here. Make a tick mark there. This will be discarded, because that will travel all the way down till it meets up to that vertex. Yep. You want to do this as calibrated as possible so that your blades are as evenly weighted as possible. Otherwise, when the blades are turning and the wind stops blowing, they will try to return back or rotate around with no wind blowing. They will try to, it's turning like this, and then all of a sudden the wind's not blowing, and they'll go and they'll flip around and tick-tock like a pendulum for a few minutes. But to prevent that, if you find out, you'll know which blade is heavy because the heavy one will come back around. Just get your snips out and trim a little bit of plastic off once in a while until you notice that they're behaving now. That's how you calibrate them. I'm making marks through here to show that I'm not going to be using a certain portion. Okay. Now I get to do the saw thing again. Should have done this in the first place, but nobody's perfect. So I'm lining up this upper mark on the saw, and I'm trying to best guess the trajectory down through there. There I am, left-handed. That's almost perfect. That one's not exactly perfect. We'll worry about that later. Kind of forgot to leave room for my Sharpie tip, the thickness of the felt. Okay. And I think this is the last one. I hope you guys didn't miss all that, but oh well. I can't do every video perfect. So, what we're after is we don't want the part that's squiggled. All right, so what we end up with, where'd the lid go? Where'd my lid go? I don't want my Sharpie drying out. All right, hang tight, I gotta pause. The lid was on the Sharpie. Durr. 10 snips to try to freehand this, but can you see what's going on there? In relationship to let me get this here. In relationship to that, yeah, Yeah, that's what we're trying to do. We're trying to prevent me having to use string to give the blades some twist. I had to engineer some string in there. In this case, I had to rotate the blade using string to give it more catch on the wind. Once this particular windmill gets going, man, it's scary to look at because it's pretty large diameter. All right. Don't need that no more. Don't need the calculator sitting there. I'm going to try to freehand this. So is this the best place to start? Or should I use my left-hand cutters or right-hand cutters? I don't think so. I think I need to use these. Okay, you guys can see what I'm doing. There's no sense in hanging out watching this. I'll get these blades cut out. I'll be right back. Hang tight. Okay, guys. So I got a couple cut out. Didn't take too long. The first one's always the hardest with tin snips. You could use a zip or something if you want to make the mess. But see what we got going on here for blades? I'm going to flatten this out down here. See how it turns. Both of them, same way. And you can get a down look at it. See how it's rotating? So that's how you make DIY, well, one way to make highly calibrated, but you're putting logic into how you're making your blades. These are laying flat down here, but they're rotating out of a piece of drain pipe. That will be the end of this video. I've got to cut out the rest and then bolt them onto my windmill and put the windmill back up. All right, guys. See ya. Have a great day. Bye.